Okay, let's face it, you're here for the kitten. That's cool, and many people on YouTube are there for kittens too. But what if the happy kitten turns into an angry fox, and the next thing you know is you're storming the Capitol? Of course, that's not how radicalization happens, but research has shown that recommendation algorithms can amplify extreme content, raising concerns that they might fuel radicalization. In our work, we develop a graph-based approach to address these concerns. We model media items and recommendations as a directed graph, where nodes have costs reflecting the harmfulness of their content. Users perform absorbing random walks on the recommendation graph, and the expected total exposure to harm is the sum of the node costs they encounter when starting at any node. We then study the rewiring exposure minimization problem, or REM problem for short, which asks, how can we minimize the exposure to harmful content by rewiring edges in the recommendation graph, that is, by replacing certain recommendations with others? Analyzing the problem theoretically, we prove that the REM problem is NP-hard and NP-hard to approximate to within an additive error, constructing a really fun reduction from minimum vertex cover. However, we also show that under realistic assumptions, the maximization version of REM becomes submodular, such that the greedy method yields a 1 minus 1 over E approximation. Based on our theoretical insights, we introduce Gamin, a fast, greedy algorithm that can reduce the exposure to harmful content with or without quality constraints on recommendations. By performing just 100 rewirings and YouTube graphs with several 100,000 edges, Gamin reduces the initial exposure by 50%, all while ensuring that its recommendations are at most 5% less relevant than the original recommendations. Through extensive experiments, we confirm that Gamin is effective, robust, and efficient in practice. If you'd like to find out more, check out our paper or come find us at KDD 2023.